This is Professor Zawolo, and today we're going to be going over another section in our series of videos in preparation for the WAEC Senior Secondary School Certificate and Mathematics Examination for Liberian schools. Today again we're going to be going over subsection C, and it has to do with measurement, and we're going to be going over the section which covers areas of figures and areas of sectors of figures. Let's see what we're going to be doing. So the first thing is that we're going to be finding the area of similar figures and figures with compound shapes. We're going to go over problems involving the areas of circles and the sectors of circles, and end the problems involving surface areas of cubes, cuboids, and the rest of them. Now, to be able to compute anything that has to do with areas, several important formulas have to be known. The area of a square, the formula for the area of a square, the formula for the area of a rectangle, the formula for the area of a triangle. And in the area of a triangle, the B is the base. The base and the hypotenuse, the base and the height have a perpendicular relationship. Then we also have the formula for the area of a trapezoid, the area for the parallelogram, and the base and the height in the parallelogram have a perpendicular relationship. And the area of a rhombus, where D1 and D2 represent the diagonals of the rhombus. The area of a circle, where pi can be considered to be 22/7 or 3.14. More often than not on the WAEC, we will use it as 22/7. Sometimes in problems involving areas, you might have to find the distance, and as well you might have to find the midpoints of a segment. So these are some formulas that you might come up handy in finding areas. So now, here's our first problem. It says that the side and the diagonal of a rhombus. So let's sketch a rhombus over here. So in a rhombus, we know that all these sides are equal. So they say the side and the diagonal are 10 centimeters and 12 centimeters respectively. So that means the side will be 10 centimeters. So if one side is 10 centimeters, the other side will be 10. The other side will be 10 centimeters. The other side is going to be 10 centimeters. So the diagonal, say this diagonal is 12 centimeters. Well, what can we do? We can connect the other two diagonals. And then we have a perpendicular relationship. That's one way to look at it. Or otherwise, we can, yes, and then we'll have a perpendicular relationship. So once we do that, this is going to split the diagonals into equal portions. So if this is 12 centimeters, if this diagonal is 12 centimeters, we're going to have 6 and then what? 6. So what we have in effect is a right triangle with the following dimensions. Well, over here is going to be 6 centimeters, and then here is going to be 10 centimeters. And so what we don't know is this. Now, if we want to find the area of this rhombus, we need to know the length of this other diagonal, which we can find by finding x and then actually squaring it. That's one approach. Another approach could be to finding the area of each of these smaller triangles and multiplying it by 4. However, let's see if we can find x here. Well, this is a right triangle. So then we can say the square of the legs, which is x squared plus 6 squared, must be equal to what? 10 squared. So we have x squared plus 36 must be equal to 100. And when we subtract, we're going to have x squared equals to 64. Take the square root of both ends. We're going to have x equals to 8. So let's try to redraw it on this end and see what we have. Maybe perhaps make it even larger so we clearly see the picture that we have. So now here's what we have. We indicated earlier that this particular length of this diagonal was 12 centimeters. Now we just formed one piece of this to be 8 centimeters. We found that means the other piece is automatically 8 centimeters. We know by rule that the area of a rhombus is given by the product of the diameter of the diagonal divided by 2. So our diagonals here will be 12, and the other one is 16. Sorry, I said 16 and I wrote 12. So let's redo that. 12 times 16 divided by 2. And what do we have here? We have about 96 centimeters squared, because 16 divided by 2 would be 8. 8 times 2 is 16. That will give us 96 centimeters squared. Let's move on to the next one. So if the circumference of a circle is 44 centimeters, so that means we have C is equal to 44 centimeters. We also know that C is equal to 2 pi r. Okay? So based on this, if we know the circumference, we should be able to find the radius, because we need to find the area of the circle, which we cannot find unless we know the radius. So now, since the circumference is 44, I'm going to replace 44, C with 44, and do 2 pi r. Now next, I'm going to divide both ends by 2 pi. Divide this by 2 pi. That cancels. So what I have here is that my radius will be equal to 44 divided by 2 times pi, and pi we are told should be 22 over what? 7. So, well, let's do the multiplication at the bottom here. So what we have is 44 over 22 times 22 is 44 over 7. And so what we have now is basically 44 divided by 44 over 7. So how can we do this? We must multiply by the reciprocal. That's 7 over 44. Put a 1 here. 44 will cancel. So our radius, which we are trying to find, basically will be equal to 7 centimeters. Now that we know the radius, we can find our area using the formula for area of a circle, which is basically pi r squared. So what do we have? Pi, radius is what? 7 squared times 22 over what? 7? Well, we can do this. 7 squared is basically 7 times this 22 here. So the 7 we cancel. 7 times 2 is 14. Put the 4. 7 times 2 is, so we'll have 154 centimeters, square centimeters. So that's going to be the area of our circle. So to do this, we have to find the radius of the circle, use the radius into the formula for the area of the circle. Sometimes these things are not stated directly, you have to read through it. Okay, so now we want to find the area of an isosceles triangle of size 5 centimeters. So let's sketch it. So if it's an isosceles triangle, remember it didn't say right isosceles, it's an isosceles triangle. So for example, if this side is 5 centimeters, then the other side is going to be 5 centimeters. So this is going to be our base, 6 centimeters. So to find the area of this, we need to know the height, h, because the area of a triangle is given by 1/2 the base times the height, and the base and the height must have a perpendicular relationship. Now, so how then can we find h? Well, if this base is 6 centimeters and I run this line through here to form a right angle here, these two ends will be equal. So this is going to be 3 centimeters and this is going to be 3 centimeters. So then, let's take this component here of the larger triangle. Let's take this portion. So this is going to be 3 centimeters. It's going to be 5 centimeters. And so we need to know, let me just keep it as h. Well, the legs here will be h and 3. So by Pythagorean theorem, h squared plus 3 squared must be equal to 5 squared. And once I'm done finding this answer, I will say something that should help you in the future be able to calculate this without doing anything. So solve for this, subtract 9 from both sides. We have h squared equals to 16. Take the square root. H is going to be equal to what? 4. Well, obviously before I even started, I knew that this was one of those Pythagorean triple of 3, 4, 5 triangle. So once a side was 3, another side was 5, the other side had to be 4. So I really didn't have to do these calculations to actually compute h. So now that we know that h is 4, let's plug into the formula for area of a triangle. So I have A equals 1/2. The base here is, here's the base, which is 6 centimeters, times the height, which we just calculated to be 4. So what we have is 6 times 4 is 24 divided by 2. And so that's going to be 12 centimeters squared. Okay? Again, we had to go around this problem. We had to compute something that was not directly asked for. We have to watch for those things as we do problems on this examination. So let's draw the diagram first. So we have a trapezoid. Let's label our trapezoid as A, B, C, D. We say AB is 11 centimeters. We say BC is 10 centimeters. We say AD is 8 centimeters. And we want to find the area of this figure. Now, the figure looks like a trapezoid. Now, the problem is that, can we use the formula for the trapezoid to do this problem? Well, we could. If we did some work. So let's do something right here first. Let's draw a line right here. And that means this piece right here is going to be 8 centimeters. So it's going to be a right triangle right here. So we can proceed to finding the length of that side of right here. Let me just call this O over here. So we can find OC. How can we find OC? Let's call OC X. So what we have here is, again, a right triangle, and the two legs would be 8 centimeters, and the other one is X. So we can do X squared plus 8 squared equals to what? 10 squared. So that would be X squared plus 64 equals to 100. Subtract 64, we're going to have X squared equals to 36. Take the square root of both sides. We're going to have X is equal to 6. So now we have calculated OC to be 6. Now, the formula for the area of a trapezoid is A is equal to 1/2 height B1 plus B2, base 1 and base 2. Let's see if we have this information. Well, the height is the distance from B to O or from A to D. So yes, we have our height. Our height is 8 centimeters. Now, we know one of the bases would be AB. So we have that base, let's call that base 1 to be 11 centimeters. Now base 2, the second base, the one at the bottom, well, we have the information to compute it, because from D to O is 11 centimeters, and from O to C is 6 centimeters. So 11 plus 6 is what? 17 centimeters. So we have 17 centimeters. So now we have all the information to complete this problem. And let's write this formula like this. H is going to be 8. B1 is 11 plus 17. I just want to divide that by what? 2. So I'm going to have 8 divided by 2. That's 4. 11 plus 17 would be 28. So that's 2. So that's going to be 1/12. Alright? So basically we're going to have our area to be 112 centimeters squared. Let's move on to the next problem. Okay. So if we were to use our formula, say the area A is equal to A degree, meaning the angle measured, divided by 360 times the formula for the area of a circle, we should be able to find our radius, then use our radius to find the entire circle. So now, the area we are told is 7.5 pi. The measurement of this angle we have here is 315 and over what? 360 pi r squared. Now, several things can happen here. First of all, the pi's can cancel. Pi would cancel with pi. And the next thing we could possibly do is to simplify 315 and 360. So let's see if we can do that. So what we have here now is 7/2 is equal to, let's see what is 315 divided by 360 going to give us. 315 divided by 360, and that is going to give us 7/8. So I have 7/8 r squared. Well, we can cross multiply here. We also cancel the 7. Let's do this. Let's cross multiply. So I'm going to keep it like this. 8 times 7 equals, because I multiply here, and I'm going to multiply here. I'm going to have 2 times 7 times r squared. So my 7 is going to cancel. Now I have 8 equals 2r squared. I'm going to divide this by 2, divide this by 2. I have r squared equals to 4. If I take the square root of both sides, I'm going to have r is equal to 2. So now that I know the radius to be 2, I can go ahead and find. So now that I have the radius, so I'm done. I don't have to find the area. So in this problem, we're required to find the radius. So our radius is actually going to be 2. We're done. Let's move to the next problem. Sector of an angle of 45 degrees and area of 72 centimeters cut from a circle. What is the area of the remaining portion of the circle? So let's do it. Let's go. Let's draw the circle. Okay. Let's mark our center. So, okay, 45 degrees. So let's do this. Let's draw it into 90s. So 45. All right. So several things we can do. We can say here 45 is what portion of a circle. So 45. So let's find 45 is what part of a circle. So 45. Let's do it. Say 45 divided by what? 360. Because we have 360 degrees in a circle. So let's do 45 is what part of a circle? 45 will be basically 1/8 of a circle. So if 1/8 of the circle was cut off, and that sector was 72 degrees, we can use proportion to find this. So we can say, look, 1/8 was equivalent to 72 centimeters. So if we took 1/8 out, the remaining portion of the circle would be 7/8. So what is 7/8 of that? So we get a proportion here. We can simply solve this by saying x, 1/8 x is equal to 7/8 times 72. And basically here we can see that our x can cancel and our 8 can cancel, and x will be equal to 72 times 7. So that's going to give us 504. 72 times, we have 72 times 7, give us 504. So the remaining portion of the circle will be 504 centimeters squared. Now let's check and see whether this is right. So 45 is 1/8 of a circle. So let's divide 504 divided by 504 divided by 8. So now what we have is that AB is of length 10. We have found the length of AB to be 10 units. We've also found the length of BC to be 5 units. So that's going to be our answer for part B, the length of AB and BC. Now remember, I said I was going to actually verify. I think we can see here that this point is actually at -6. So this is point D. Let's clear it out. So D, which was AB, we need to find the coordinate of A and B, which will be the answer to part A. So it looks like this is going to be what? -6. Now that it looks like it's actually x coordinate is -6, and the y coordinate for this point right here is actually what? 4. You can verify that and see. So now we have the answer for part A, part B. So the length of AB is 10, the length of BC is 5, and the coordinates of D is -6 and 4. That means A is equal to -6, B is equal to 4. So let's go back to the previous previous slide and put that in. So determine the values of A. So again, we say that A is -6 and B is equal to what? 4. So let's move on to the last part of the problem. Now, for this one, we need to find, let's go back, we're too fast. Now, we have to calculate the area of the rectangle. Well, remember, we found the length of that, we found AB and BC constituted the length. We can take this as the length and width of the rectangle. And the formula for the area of the rectangle is equal to length times width. We calculated AB to be 10 units. We calculated BC to be 5 units. So that means it will be 50 what? Square units. Thank you, and I hope you can take some time to visit us online and do some practice on these kind of problems. Thank you.